Okay, today is October 1st. We're going to go over domain. Let's just take like a brief trip down memory lane on what we have been doing in this unit. You don't have to turn your pages, I'll just turn mine for you. So we started with evaluating functions. So we take a value, we plug it in, we get a value out. Then the next thing we did was start talking about these graphs. And the connection is, if you plug different values into a function, what ends up happening is that they make these graphs that you see on your function, your family functions page. So we practiced talking about how, well, we didn't practice talking about it. We practiced identifying what had happened to a parent function. So had it been shifted, had the size been changed, had we reflected it, and then we talked about vertex form. So we went from evaluating functions to using that for graphing functions, and now what we're going to do is talk about the domain of a function or the domain of a graph. So we're going to skip page 20 because we did that on this worksheet that I gave you last time. We already practiced this graphing that is on page 20. So we are going to move on to page 21. I think for some of you guys, this might be a review. Regardless, hopefully it is not too hard. So the domain of a function, sorry, I should zoom in, is the set of all possible x values. So x values, that means we're going to be looking at the x-axis, and oftentimes that means that we are going to have more than one number. So we want to make sure that we're seeing that it is all of the possible numbers that x can be. It is all of the possible numbers that x can be. So what do we mean by that? What do we mean when we say it's all the numbers that x can be? Well, just like we talked about on the evaluating functions page, we put a number into a function and get out a different number. But sometimes you put a number in the function and your calculator gives you an error. So you'll try to plug in a number and then it will give you back, at least on these littler calculators, it'll tell you that you have an error. So some numbers you won't be able to plug into a function because it'll give you an error. What we're going to focus on, though, is the things that we can plug into the function. So we're going to identify all the things we can plug in. So the first set that we have, you can actually write down all of the numbers that x can be. So on this first set, x can be the number 0, comma, 2, comma, 5, 8, 11. How do I know it can be those numbers? Because this table tells me. This table gives me all of the x values for my function. It cannot be any other numbers. So it cannot be 1. It cannot be 7. It cannot be 50. The only things this function can be is 0, 2, 5, 8, and 11. Now to make this really nice, we're supposed to put fancy brackets on it. So a fancy bracket, if you do it like the easy way, you do like a parenthesis, and then a triangle, and then a parenthesis. That's your fancy bracket. Do you really got to write these? Yes, you do. If you want to do a curved one, you just don't pick up your pencil. See what's happening there? Are you guys making your fancy brackets? Let's make them. Let's do it. Let's do this thing. So when we write down the set of numbers that x can be, if we can list out all the numbers, we usually put fancy brackets around the numbers. Okay, so we have a table. Next up is a graph. So because we have a graph, what we are going to look at is the x-axis. Because we only care about what numbers the x can be right now. So I'm going to start from the left-hand side, and I'm going to write down the x values that match these points. So this one right here, this is 0, 0. That's your origin. Where the two axes cross, that's your origin. So we have 1 point at -2 on the x-axis. So on the green, it lines up with the green line. Okay, so where is this point at on the green line? -1. It lines up with -1. Okay, this point lines up with 0 on the green line. Maybe I should use a color. I'm just choosing a color. Okay, what does this line up with on the green line? 1, and then this one, 2. So those are all of the numbers that x can be. We have -2, -1, 0, then we have 1 and 2. So 5 numbers, and we put the fancy brackets on it. So on this function, it was 5 numbers. On this function, it was 5 numbers. On this function, it's only going to be 4 numbers. So we had a table, we have a graph, and now they're just giving us a list of points. So remember, all of your points go in the order of x, y. All points go in the order of x, y. So if we want to know the numbers that x can be, we are going to do the numbers that are in the x position. So I went through for the 4 points that they gave us and identified all of the x values. Now, when we list, we want to go in the order from least to greatest. So in this case, the smallest x value is -5, then 0, then 5, oh, just kidding, then 3, then 5. Sorry about that. So these first 3 examples are the easier ones. These are domains where you can actually list out the number of values that x can be. Now we're going to make it much more complicated. So we're going to look at a circle. So I have, let's say that this is 0, this is -2, and this is +2 on our circle. So remember, when we talk about, well, what value can x be, we see if there's a part of the graph that matches up with that x value. So if I put a point over here at -3, can x be -3? No, because the circle goes from -2 to +2. So x cannot be -2, or sorry, -3. Can it be +3? Can it? Nope. Can it be 2.5? Can it be 2? Yes. Can it be 1? -1? Yes. And if you're wondering, the reason that it can be is because these points are inside of that circle. So they match up with these on the circle? Okay, well, can it be 1.5? Yes. Is it in the circle? Yeah. Can it be 1/2? Can it be 0.75? What about 0.25? What about 0.10? Yep. What about 0.20? What about 0.15? Can you guys see the pattern here? If you have a circle, it turns out that X can be all of these numbers, all of the numbers that you can think of between 0 and 2. There's infinitely many numbers from 0 to 2. X can be all of these numbers because these are all inside the circle. Do we want to list out all those numbers? No, it'd be impossible to list out the numbers. So instead, what we do is we write a shorthand for what X can be. So in this case, we know that X starts at -2 and goes all the way to 2. And the shorthand is that we would put square brackets around these two numbers. Square brackets mean X can be any number from -2 to +2. So X can be any number that's on this number line between -2 and 2. Okay, so let's look at our examples then on this page. So when a function is continuous, you start on the left and you move right. Okay, so I'm going to zoom way in because this guy's got something interesting going on. If you look very closely, can you guys see how he has an open point there? If you have an open point on your graph, that means that X cannot equal that number. So maybe we should write that down somewhere. I'm going to write this down at the very bottom of my paper. I'm going to say, if I have a point that is open, this means not equal to. If I have a point that is closed, meaning it's filled in, that means equal to. So if it's open, that means X can't be this number. If it's closed, that means X can be the number. So now if we revisit number 4, we can see that on one end it's open and on the other end it is closed. So first thing that we need to do is identify where is that at on the x-axis. So go to your graph, count to the left to figure out where is that open dot on your x-axis. Are you doing it? Do I need to pick sticks? Maybe I should. Diamond. Oh, dang, girl. Do you guys agree? -7. Then we can be any number from -7 all the way over to whatever this X value is. What's this X value? +7? Are you sure? Comma, +7. Okay, well, on the circle example, I told you that we could use square brackets, but you can only use a square bracket on the 7. You can only use a square bracket on the 7 because square bracket means equals. So then, what do we use on this to show that it cannot equal -7? Parenthesis. So now what that means is This can be any number from -7 to 7. It cannot be -7. So sounds like most of you guys are familiar with interval notation. Is that true? So let's just, for our own reference, make sure that we have the different symbols. So this means, square bracket means equal to or included. Square parentheses or square brackets means it can be equal to or included. Parentheses is not equal to or not included. And you can mix and match them. I'll give you about 15 seconds and then we'll move on to number 5. I have a feeling lots of you guys already have it done though. Okay, so number 5, we've got a point on the left-hand side and a point on the right-hand side. Both are closed. So we identify where the origin is so that we can count what our x value is. So there's 0, 0. So what's our lower bound? What's on the left-hand side? -2. That is our lower bound. He's a closed dot, so we say square bracket, comma. Now we come over here to our upper bound, our upper boundary. What's that number? 4. Closed circle again, so that's a bracket. Okay, this guy's different. What's different about this guy? It's what? That's okay. What else is different about him? Can you guys see that? This is not a point. This is the first one where one of your bounds is an arrow and the other one is a closed point. So your x-axis is hanging out down here, and that's okay. We can still use them to figure out our values that x can be. So this is our lower bound. What does that equal? 3. It's a closed dot, so you do brackets. What does this arrow mean? Goes on forever and ever and ever and ever. So in the right-hand direction, forever and ever is infinity. Oh, really? Full send, I win. Okay, can any number really equal infinity? No, because infinity's pretend. It doesn't even really exist. You can't be equal to a number that doesn't really exist. So infinity is always a parenthesis. Always, always, always. Infinity and negative infinity are always parentheses. So anytime you see an arrow, it's either negative infinity or positive infinity. So now, oh dang, look at this guy. He's our first one with 2 arrows. This is our first one with 2 arrows. So that means on the lower bound, this arrow is going to go to negative infinity. Even though it looks like he's pointing up, eventually he's going to hit infinity because he keeps moving out further and further and further to the left. So that means it's similar for the right-hand side. Where's the right-hand side going? Infinity. And once again, even though it's pointing up, it's still going to go on to the right forever. Okay, what is this called? Besides negative infinity to infinity, what else do we call it? Do you guys know? All reals. This means that x can be any number. X can be any number. If it's all reals, there's no restriction on what you can plug in for x. Okay, this guy. Oh boy. We got an upside down parabola. We got two arrows. Okay, even though these arrows are pointing down, it's still going to negative infinity and positive infinity. Even though it looks like they're going down, if you let this parabola just go on forever and ever, what ends up happening is that that parabola just keeps getting wider and wider and eventually will hit negative or positive infinity. Okay, did you guys notice this little guy jamming out right there? See that little guy hiding? Look at him. Look at him. Do you see him now? Disgusting. So we have to make sure that we address what is happening there, because that is an issue. So what we're going to say is that this can be all reals, but what number? What was that number? 1. All numbers but the number 1. This is called a point of discontinuity. So that's fancy way of saying this function is continuous and goes on forever in both directions, but we have one point that's an issue, and that's at 1. He tried to sneak in there. It's a good thing I'm a boss. I found him. You go, ma'am. No miss. Ma'am. I can't handle the miss. I can't handle it. How dare you, Hugo, be polite and call me miss. You call me ma'am. Okay, ready for the last one? Okay, we got an arrow situation and an open point situation. So you guys try this one without me. You give it a try. Oh, this guy's like in the middle. So use a 0.5. Okay, about 10. Five. 3, 2, 1. I got negative infinity to 3.5. Ugh, I did it wrong. Teacher. These should both be parentheses. Is that what you guys got? Yeah. You're sure? Yeah. Okay, now, oh no, we thought we were done, but we're not, because look at this guy jamming over here. Ugh. So now we have to do inequality notation. We got to do inequality notation. I'm just picking a color, hoping that it'll make me feel better about life. This one's good. Okay, so inequality notation is when you use things like less than or equal to, greater than or equal to. So what do these match up to? If you see an arrow pointing toward the left, or you see a parenthesis, you would use a less than, because that means not equal to. If it's an arrow, that means it's going to negative infinity, and we cannot equal negative infinity. If you see a point or a bracket, that's going to be a less than or equal to. And now it's similar for the greater than. If you see an arrow pointing toward the right, that's going to be a positive infinity. You may also see a parenthesis. If you see a point or a bracket, that's going to be a greater than or equal to. So now we're going to match these up to what we have in our interval notation. So we're going to start here at the negative 7, 7. If there are two numbers, it's a sandwich. If there are two numbers, it's a sandwich. So what do I mean by that? You're going to put x in the middle, negative 7 on the left, positive 7 on the right. Then we fill in our symbols. So if I look up at the graph, it's an open point. If I look at my interval notation, it's a parenthesis. So if I match that up down here, what is this, open? Oh, this is open. It's a less than. Uh-oh, write that in. If it's an open point, write that in. Which means on this one, it could also be an open point. This one could be a left-hand arrow. This one could be a right-hand arrow. Either way, your symbol is pointing in the direction of the arrow, if you have an arrow. So, open point, parenthesis, that means we're going to go with a less than. We're going to go with a less than. Then on this side, close point, square bracket, so that's going to be a less than or equal to. A less than or equal to. If it's a sandwich, you always do the alligator open to the right. If it's a sandwich, you always have symbols that are pointing to the left and open to the right. Are you okay there? Are you sure? Okay, next one. Okay, this is another sandwich. How do I know? Because there are two numbers. So I'm going to put x in the middle. I'm going to put negative 2 on the left, positive 4 on the right. I'm always going to have less thans, so I'm going to fill those in. But then I'm going to look at the graph or the bracket to see if I add the equal to. So close point, bracket, so this can be less than or equal to negative 2. And this one is less than or equal to 4. Are you guys okay with that one? Yes, no? Maybe? Okay. On the next one, is he going to be a sandwich? No. If he is not a sandwich, you do not include infinity. You use the number that is in the bracket. and x goes on the left-hand side. So you leave out the infinity, you keep the number in the interval notation, and x is always on the left-hand side, always. Do not ever put your x on the right-hand side. Don't do it. It's horrible. X always on the left. Okay, now we want to look at the direction that our arrow is pointing. He's pointing which direction, left or right? Right. So that's how you put your symbol. You point it right. And then, can it be equal to 3? Yes, because it's a closed dot. So this means x can be any number if it's bigger than 3. Bigger than or equal to 3. And that's what we're seeing here. This graph goes from positive 3 all the way to infinity. You're hanging in? Yes? Was that a yes? This guy stays the same. There's no inequality notation for this guy. This guy stays the same. This guy, we do not include the negative infinity. We keep the 3.5. We put x on the left always. Then we go up to our graph and we look at the direction the arrow is pointing, and we have to point our symbol in the same direction. Then you go to the other side. If the point is open, you don't put in equals. If it's closed, you put in equals. So do we add to this symbol? No. No, we do not. Okay, now that we did that, I want to verify that I have these correct. Situation happening. Yes. But on this one, I guess the brackets can be both directions. Okay. I'm going to look into my symbol situation while I have you try some. Now, here's the thing, lovies. It feels like it's been 4 hours, but really it's only been 30 minutes. And I'm sure we've already forgotten about these guys. Remember, there are domains where you can actually list out all of the values that x can be. Or you can get these crazy ones. You can get these crazy ones, and then you have to use an interval. Okay, we're going to practice now on your whiteboard. If you didn't bring your whiteboard, maybe you have one in the front cover. Maybe you should write really big on your notebook, like ginormously large. Okay, here's your first one. I don't care if you use interval notation or inequality notation. It is up to you. I'll give you like 45 so that you have enough time to... Right here, babe. You can just take it. Thank you. Yep. What color did you do? Did you get a letter? Yeah. Okay, about 30.
I did all of it gray, and then the hood and the button.
20, 10, 3, 2. Okay, show me what you're thinking. Yeah, there's more markers right there. Okay, negative infinity to infinity or all reals. Okay, next up is this guy. About 30. Ten, 5, 3, 2. Okay, show me. Negative infinity to 4 with parentheses. Both are parentheses. Oh, this one's a good one. I don't like that one. Do this one. This one might seem tricky, but he's not. I promise. Okay, 10. 5. 3, 2. Okay, show me what you're thinking. Oh, bless your souls. All reals. Very good. Oh, this is a good one. Okay, next up is this guy. Ten. 5. Okay, show me. Ooh, look at your fancy brackets. Okay, 3, 4, 5, 6. Next up is this guy. And if you don't see open points, assume that they're closed. So if you don't clearly see open points, assume that it can equal 0 in this graph. Ten, 5, 3, 2, 1. Square bracket 0 to 360. Okay, next up. Ten. You can just go big. 5, 3, 2. Okay, show me. All rails, negative infinity to infinity. Okay, 2 more. Sky. Ten. 5, 3, 2. Okay, show me. Negative 4 to infinity. The negative 4 has a bracket. Okay, last one. Ten. 5, 3, 2. Okay, show me. Excellente. Negative 4, negative 2. I forgot the rest already. 1 and 3. Okay, we're done now. Distance learners, you go do your quiz 2.3.